Assalamualaikum. Today we are excited to present our group project titled Automation of Cutting Hacksaw. This project was carried out by me, Rashikin, Nur Shahada and Nur Alia. Our focus is on creating a semi-automatic hacksaw machine to enhance efficiency, safety and learning in university workshop. Okay, first of all, the background of the project. As we know, automation has transformed workshop tasks, making them faster, safer, and more precise. Cutting material, often done with manual hacksaw, is an essential task but comes with challenge. Manual hacksaw are cheap and simple, but are tiring to use, lack of precision, which lead to material waste. Our project addressed this issue by introducing a semi-automatic hacksaw machine that combines precision and efficiency while helping students learn in educational settings. For problem statement, our research identified two major challenges. First, manual tools issue. Manual tools are tiring, imprecise, and lead to material waste. This issue makes it hard for students to learn effectively. Second, fully automated tools issue. Fully automated tools are expensive and overly complex for basic educational purpose. Thus, there are need for a cost-effective semi-automatic solution that bridge this gap. Okay, for objective, our project has three main objectives. First, to develop a robust and reliable drive mechanism to ensure smooth and efficient operation. Second, to design durable structural components that maintain stability and alignment during cutting. Third, to create an effective cutting and control system that allow precise and user-friendly operation for various materials. For my last part is project scope. So our project focused on developing a semi-automatic hacksaw machine for university fitting workshop. So the key features include a motor-driven blade mechanism for cutting, manual control for material positioning and clamping, emphasis on safety, ease of operation, and compatibility with educational requirements.
Now, I would like to share about our expected outcomes. We have four expected outcomes. First is development of a functional semi-automatic hacksaw machines for cutting my steel, rods, and plastic pipes. Next, ergonomic design to minimize user strains and simplify operations. Third is incorporation of a robust drive mechanisms and durable components for reliable performance and precisions. Lastly, a cost-effective, low-maintenance solution tailored for educational use in university workshop. Okay, this part I will talk about our literature review. First is introductions. We focus on cutting techniques and hacksaw machines for semi-automatic solutions, and we cover challenges, safety, sustainability, and engineering aspect. Next is cutting hacksaw processes and challenges. The method we use is manual, semi-automatic, automatic, and automate. And last is the challenges: inconsistency, fatigue, material waste, and cost concerns. Next is engineering analysis. We evaluate forces, stresses, and operational efficiency for durability and safety. Next, we have existing cutting techniques. We have some cutting techniques. First is manual hacksaw, which simple, portable, require efforts and lack of precision. Next, we have power hacksaw, which faster, consistent, needs electricity and higher cost. We also have bandsaw, which versatile, precise, expensive, and safety concerns. We also have circular saw, fast, clean cuts, noisy, and not for curve. Last, we have hydraulic hacksaw, which precise, portable, costly, and complex maintenance. Last point in our literature review is design consideration. First, we consider in safety and health, which protective barriers, ergonomic designs, noise or dust control. Next, we have cultural and social, which inclusive designs is of use for students. Next, environmental. We use this of recyclable materials, low energy consumption. Last but not least, ethics, which transparency, affordability, responsible sourcing.
So my name is Nurshada binti Abdul Rosli, and I will talk about the methodology. So now I will explain the methodology we use for creating our semi-automatic hacksaw machine. This is the step-by-step process we follow to design and build our machine while ensuring it's efficient, safe and easy to use. So let's look at each step in detail. First, for the first step was design formulation. This means we figure out what the machine needs to do and how we could make it work. For the key requirement, it has 3 key requirements. For the first one, the machine should cut smoothly and not require much physical effort. Next, it had to include safety features like blade guard and emergency stop button. It also had to be lightweight, compact and easy to move around so it could fit in a workshop. We also decided to use a motor to power the cutting blade and a strong steel frame to keep everything stable during use. This helped us to set clear goals for our projects. Next, for the concept design, we came up with 3 design ideas and we compared them to find the best one. For the first model, we use a pneumatic system which is simple and affordable, but it needs an air compressor which make it less practical. For the second model, it had a flywheel at the back, making it a bit more balanced, but it took up too much space and was harder to maintain. For the last model, the final design had the flywheel at the front, which made the machine more stable and easier to maintain. We chose Model 3 because it was the best balance of performance, durability and ease of use. For the configuration design, now we turn the chosen design into a working setup. We use a motor and crank mechanism to make the blade move back and forth. The frame was made from strong steel to reduce vibration and keep the machine steady while cutting. We also add adjustable clamp to hold different material in place securely. This design was compact, easy to use, and perfect for a workshop setting. So for the parametric design and prototyping, in this step, we use SolidWorks software to create a detailed 3D model of the machine. The frame and base were made from mild steel for strength and stability. The cutting system used a high carbon steel blade for precise and smooth cut. We also add a flywheel to keep the cutting motion steady and efficient. We carefully chose material and design to make sure the machine was durable, cost-effective and easy to maintain. So for the sustainability and safety consideration, for the safety we add an emergency stop button and a clamping system to keep material in place while cutting. The design also reduces user strain with an ergonomic setup. For sustainability, we use recyclable material like mild steel to reduce waste. The motor was an easy efficient, which means it used less power but still worked well. This way, the machine is safe for user and better for the environment. So, in conclusion, to wrap up our methodology, follow a clear and simple process. We start by understanding what the machine needs to do. We explore different design ideas and pick the best one. We then turn that design into a working safe and efficient machine. This result is a semi-automatic hacksaw machine that's easy to use, safe and environmental friendly. It's perfect for university workshop where students can learn while using a practical tool. So that's all from me. Thank you.